So we're moving on now to a really interesting presentation from Russell Davis from Organix on worm-powered wastewater solutions. He's the president of Organix, and Organix is based in Walla Walla. Russ is a leader in solving issues surrounding dairy manure management. The organization was founded in 2001 specifically for the purpose of managing dairy nutrients as one of the largest dairy complexes in the nation, the Columbia River Dairy in Boardman, Oregon. In 2015, Organix teamed up with Chilean wastewater treatment firm BioFiltro, who now has over 180 wastewater systems installed around the world. Russ?
Okay, hello everyone. Russ Davis with Organix, based out of Walla Walla, Washington. I've been in this area of industry, primarily around dairies, cleaning up dairies and composting treatment systems for organic waste for about 25 years now. That went by fast. But the topic today is going to be BioFiltro. BioFiltro is a company that we partnered with a few years ago. They're based out of Chile. They came up with a system that essentially treats wastewater with for those of you who are familiar with worm composting bins, it's kind of a fascinating large version of the worm composting. And we remove 90% of the potential contaminants from wastewater. And so our first target, you see here this guy holding stuff in his hand, that's up at a facility that we have in Royal City, Washington. It's about 7 acres now, and we treat about 500,000 gallons per day. So let's see this. Okay, so the BioFiltro system, it's patented wastewater treatment system, uses worms to make some important impacts to wastewater, including BOD reduction, suspended solids, nitrogen, ammonia, fats, oils, and grease, phosphorus, dissolved solids. The system is robust. Worms, the Cinia fetida worms, are pretty tough, and so we've had pretty good success so far. This is kind of a cross-cut of the system. It's essentially, if you were to see one of these sitting out in the open, it looks like a concrete box. On the outside, it's filled with a series of substrates, and the primary substrate is shavings or wood chips, which is where the worms live. Their job is to basically keep the filter clean. Down below that, there's some matting that separates the rock beneath it and the chips above it. And then down at the very bottom, there's kind of there's some plastic pallet type devices that hold everything up. So we try to keep the whole entire time the system is aerobic, and that's really the primary benefit of the BioFiltro is it takes anaerobic water, lagoon water from a dairy or from a winery or from a municipal treatment plant, and turns it into an aerobic water, which eliminates the methane and some other contaminants. So the worm here pictured is an Cinia fetida. They basically burrow into the system and keep it clean like a janitor, sort of our filter. They operate in a pH range, preferably between 5 and 8, but we get down to 4 in some wine applications and sometimes 9. They live 6 to 8 years. They reproduce quickly, about 4 per week. Of course, the product they make in this process is castings, which is, everybody loves worm castings. I yet to find someone that says, oh no, no worm castings. So very stable environment. This is not a high energy user. It's simple to operate. No one ever falls in a BioFiltro and can't get out because you can walk in there and walk out. So the goal is to target the soluble and dissolved solids. And obviously, once you start these worms in a large project like we have up in Royal City, it's a large colony. They create this biofilm, kind of a biome, that essentially digests additionally what the worms don't eat on the way through. It treats the water on the rest of the way. So it's kind of a very simple version. At a dairy, you'd have a primary solid separator. Also at a winery, or basically anyone who's got solid waste or water that has solid waste in it. There's an EQ tank to make sure we don't shock the system with a really low pH or a very high pH, and also to make sure that we're running the cycle, which is about 30 seconds on and about half an hour off. It takes about 4 hours from the water time it's applied to the bottom of the system where it's collected and sent back to be reused in some other application. So pre-solids treatment, there's usually a rotary screen, sometimes a parabolic screen or a slope screen. DAFs, which use polymers, which not anyone really I was really excited about using polymers, but in some cases where you have high solids, you have to. We generally don't go behind DAFs because we don't like the polymer that sometimes can get tangled up in the water. But we can do all three of these. We can treat water post all sort of pre-treatment. Just kind of an idea of what the plants are the BioFiltro has out there. When I first found out about them, they were working out of dairy down in California. And I thought dairy was their primary business. I quickly learned that it's only about a small portion of their business, and half their business was sanitary waste. So we've been making some strides in the sanitary department. We've got 3 units in Walla Walla. One is at a winery, one is at a juice plant, and one is at a port. And they've been all testing variable things, primarily trying to see if they can reduce the VOD and TSS. BioFiltro's got experience all around the world now. There's a unit in Antarctica at the naval station. People think that's surprising, but it's not. It's not a heated unit. It's covered so that the snow doesn't pile up on it, but it can handle very low temperatures because the worms move together to stay warm. There's also one in the Atacama Desert in Chile, the hottest place on Earth, and there's like a rest area, a rest stop there where this is a little project, Wise Villa Winery in California. This is what would be considered an M2, a single M2. There's a worm bed on top behind the screen there, and there's a worm bed also on the bottom, which is kind of a new development for BioFiltro. They originally had just one bed, and they figured out a way to engineer a second bed. You can't use this in applications where there's rock. So we don't use rock, for example, at a winery because it's not necessary like we would in a dairy. So it's a little lighter on top. This unit does about 1,200 gallons a day. 1,000 gallons per day unit. This is custom made. It's the look they wanted. It's the round tank style. BioFiltro's kind of moved away from these because just the complications. And it's 1,000 gallons per day, and you can actually pull a unit in and drop it off, and processing water literally within a day or so. Peltier Vineyards down in California. It's just kind of a smaller winery from some of the things that we've done. These guys are very concerned about how they treat their water. That's 10,000 gallons per day. This is the Finelli dairy that I had originally found out about back in 2015 in California. They do 15,000 gallons per day. It's been very studied by NRCS, USDA, and UC Davis, and they found all kinds of information. There's some great studies available on this project. Wanna Frozen Foods, just a company that does agro processing. 3,000 gallons per day currently, but they jumped it up to 50,000 gallons per day by adding additional units, as you can see in the background there. This is just to show you that you can put a BioFiltro pretty much right in the middle of a community, and the odor reduction is about 90% in the water. So if the water is a source of odor, it's because of the aerobic treatment, it's almost eliminated. 80,000 gallons per day. This is a rest stop / McDonald's / Chevron gas station location, Firebach, California. It's kind of a wide spot on the road where people stay, and they didn't have a significant treatment system in. They put in this unit there, and we screen the solids off, which go one way, and we treat the water there at that location, 80,000 gallons per day. This is the Fetzer Vineyards project in California. They did a nice video for us. It's their own. It's kind of a cartoon video. You can find it online. But it's basically a story about worms and the work they do inside the Fetzer Vineyard project. And they're a B Corporation, so they really like this kind of stuff. This is the Royal Dairy project. It can go up to 750,000 gallons per day. I think we're processing currently around 500,000 gallons per day. It's 7 acres of BioFiltro. It's a large project. This is at a winery. The water goes in looking kind of bluish, purplish, and then it comes out looking like this. There you can kind of see headworks, and then after the solids, and then after the BioFiltro. This is the Chilean facility, 30,000 gallons per day. It's covered not for heat, it's just covered to keep the snow off. This is the little unit that we have. Demonstrations with this unit, for example, someone says, hey, I've got a situation where I just want to test like 300 gallons per day. This is a unit that we dispatch for something like Concrete system lasts about 25 years. The tanks, 20 years. Worms last between 6 and 8 years. We've never actually checked that, but that's what the scientists say. They can handle a high EDC and a pretty wide range of pH. In some units, depending on how it's working, we'll remove the castings either every 36 months at a winery. It's a little less than that for a dairy, about 18 months. Those worm castings are fairly valuable, which is one of my primary interests in this business. Being able to get our hands on that casting material. Looking forward to large quantities of that. We've already started doing some harvesting. Okay. All right, so there you go. This system is at a winery. It's all based on how dirty is your water, how much water do you have, how clean do you want it. And these are kind of general terms of how the gallons per square foot based on the type of effluent. You can see you have a much higher rate of treatment in dairies. You can only put 2.5 gallons per square foot, whereas a sanitary waste unit maybe 11 gallons per square foot. Okay. So the BioFiltro pitch is it's a complete turnkey system. It is fascinating. I mean, I feel like sometimes I'm talking about witchcraft when I talk about the system, but it really works. It's just worms treating the water like they're meant to do. A lot of the systems are installed on a per gallon basis, so if it doesn't work, the customer doesn't pay. You can set it up so that a client can pay cash for the unit, the operation over time. There's several versions of this, and that is pretty much it. So BioFiltro is we're in a partnership with them. Organix does composting, solid waste management for multiple applications, but this is our primary water treatment system. Super satisfied with it so far, so good.
Great, thanks so much, Russ, for that presentation. We've got about 5 minutes also for questions. Heather, I think Heather Trim might have the first question.
Cool. Well, Russ, I love this. I love worms. Now, I used to have a worm bin when I lived in Southern California, and it did have a problem that occasionally the worms would die because I put something in bad that they died, and they all died. So I'm wondering, I mean, now you have this huge system. What happens if something disrupts it and they all die? And then the other question I have is, how long does each worm live? I never could figure that out. Do they live for like a year, a day, a week? I never could figure out the length of age because it seemed like there were all little babies coming all the time. Anyway, please enlighten us on worms.
Okay, well, to answer you on the length of life of a worm, they say it's between 6 and 8 years, and we've never really been able to measure it. We're just assuming that the scientists know what they're talking about. But they continue to double in population every 3 months, I think. So once they reach a point at which the unit there's enough food and enough worms and enough space, they essentially stop adding to their population. So that was the first thing. As far as what can kill off, like a large kill off of worms, one of the things that I like about the BioFiltro versus an anaerobic digester is you can upset an anaerobic digester very easily and basically kill all the biology inside. You just drain it, start from scratch. BioFiltro is pretty robust. The worms are able to treat all kinds of interesting things, learning more by the day. The only thing that really can cause a kill off of the worms is a very low pH for an extended period of time. So, for example, 3 or 12, for some half a day or something like that. And they'll try to move away. They're pretty smart. They try to find what places they can go to get away. But it doesn't happen very often. Since I've been working at BioFiltro, I don't think we've had an entire kill off at any location. So it's not a very common occurrence.
We've had a question come in about the growth medium. What types of growth medium substrates are used for the worms?
So depending on the application, it's always wood-based, but depending on the application, where there's a low total suspended solids level, for example, at a winery or a sanitary facility, we would use shavings because they have a tendency to kind of stay fluffy. They're small, they don't compact. At a dairy, we found out the best answer is chips. A little more airspace, a little more able for the material to move down inside to where the worms are. We tried shavings initially at the dairy on a test unit. That was a disaster. Immediately, basically plugged on top. And of course, when it goes anaerobic, then you've lost everything. So the chips, though, have worked pretty well. Application rate, chips, is kind of determined by the TSS coming into the substrate, but it's always wood-based so far.
And then we've had a question come in around the sort of general size or the typical size of installation. Do you have a typical size, or is it all shapes and sizes?
It is all shapes and sizes, but I will tell you that the Royal Dairy project is kind of it's an anomaly. It's pretty large. That's a 6,000 cow dairy. There's about 450 dairies in Washington State, and I would say average size is probably around 600 to 700 cows per dairy. So in that application, I mean, that would be a large group of dairies that would fit into that category. So it depends on the client, but some of it's real estate restricted, so downtown projects are difficult because we don't have enough land. But it seems like, you know, under an acre is the general size.
Does performance decrease in cold temperatures? Do worms like it sort of like nice and warm and cozy, or do they operate at pretty low temperatures too?
The worms never stop processing the water, but they do slow down a little bit when it gets really cold. They just move down inside the box a little bit. Most of the problems that we have with cold temperature are just making sure the pipes don't freeze. And so what we do often in that case, we increase the application with a smaller amount of water. So instead of 30 seconds every 30 minutes, it might be 10 seconds 3 times over 30 minutes or something like that. That's generally how that works.
And then thinking about the sort of effectiveness of the worm sort of like taking, you know, materials that we're not too happy about from the kind of effluent, how are they at removing heavy metals and pharmaceuticals?
I love this question. So we are currently doing a couple studies right now where we believe, based on what we've known just for some initial testing, that we think the worms will be able to help remove antibiotics from not only the dairy stream, but potentially human waste streams. We've done some testing on PCB removal. We've had up to 99% PCB removal in wastewater, and Walla Walla is kind of known for that. Spokane's got some of those issues. So now we're looking at PFAS products or contaminants. I think that it's really, every time we go through a door, there's 10 more doors we need to go through. So far, so good. I really do think that the worms are probably the most robust biological treatment system.
Sorry, I had difficulty unmuting myself. One final question. What do you do with the dead worms?
It's a good question. Yeah. So, well, worms, of course, are omnivorous. So they generally, if a worm dies, it becomes part of the substrate, and they just decompose into the substrate. Very seldom. I can't really think of a good time, except maybe on a demonstration, where you reach in to grab some worms you pull out. You never see a dead worm. So we just tell everyone they don't ever die.
And on that not at all scary note, I want to thank you, Russ, for your presentation and follow-up questions. They were super interesting. So thank you.